Hi, today I'm going to talk about parametric equations, and let me first start off by explaining the differences between a linear equation and parametric equation. See, when you have a linear equation like this one, and you have an object, this linear equation tells you all the possible places where the object could be. But the problem is, it doesn't tell you the specific place that object could be corresponding with a specific time. So if you wanted to know exactly where the object would be at a certain time, you'd have to add a new variable or called t, and that's the parameter. And with that, you get a parametric equation. And to get a parametric equation, you set x and y as both of them as functions of t. And that gives you a parametric equation. So, for example, this y equals 2t, and then x equals t squared, with t being between 0 and 4. So you would plug it in to the table, pretty self-explanatory. And then when you graph it, you get this parabola. But since you know the direction it's going in because of t, and since when t increases, it moves up, you have to put these arrows so you know now where the object would be corresponding with a specific time. And make sure when you graph these, you have to use arrows. And then another thing with parametric equations, let's say like this, if you wanted to put this in rectangular form, all you would have to do is eliminate the parameter, or in other words, solve for t. So you would get, so let's start with y equals 2t. So what you would do is you would solve for t, so it'd be t equals y over 2. And then you would plug that back into x equals t squared. So it would be x equals y over 2 squared, or x equals y squared over 4. And since you know, because of the parameter, that y, it doesn't, y isn't negative, you would have to set the domain as y has to be greater than or equal to 0. So now you know how to, basically what parametric equations are, how to graph them and solve for them, and how to turn it back into rectangular form.